Today we're talking about relations and functions. A relation is a set of ordered pairs. The ordered pair is x followed by y. The domain is the set of the first coordinates of the ordered pair. That means that domain is all the x's. And the range is the set of the second coordinates of the ordered pairs. That means that range is all the y's. If we have to find the domain and the range of the data in the table, domain represents the x, range represents the y. So that means the domain is all the numbers in the x. In this case, we would write -2, -1, and 4 as the domain. -2, -1, and 4. We've got the 4 repeating and the -1 repeating. Notice that when I list the domain, I only write them once. Because we need to list the range. The numbers in the range are -2, 1, and 3. The 3 and the 1 repeat. -2, 1, and 3. And I listed the numbers in numerical order. A function is a relation that assigns exactly one value in the range, which is the y, to each value in the domain, which is the x. One way you can tell whether a relation is a function is to analyze the graph of the relation using the vertical line test. So this is the graph of the relation. That means that the points are plotted on the graph. To analyze this using a vertical line test, we can draw a vertical line over each point we draw a vertical line over each point and it passes more than one point. So right here it passes the vertical line test because the line only passes one point. Here it passes 2. Let's check over this point. It passes. But let's see this one. Does it pass the vertical line test here? It does not pass because the vertical line passes more than one point. So this relation is not a function. Use a mapping diagram to determine whether the relation is a function. So to create a map, we have to list our x's and then our y. In our x we have 11, 12, 13, and 20. And in our y's we've got -2, -1, -2 again, and 7. So -2, -1, and 7. If one of them repeats, we don't have to write it twice. We're going to connect our ordered pairs. So 11 to -2, 12 to -1, 13 to -2, and 20 to 7. Would this relation be a function? Yes, this relation is a function. For every x or for every domain, there is exactly one y. If the domain does not repeat, if for every domain there's exactly one y, then yes, it is a function. If we have to evaluate f of n equals -3n minus 10, that means we're substituting n for 6. So what do we get as an output when our input is 6? That means when we're substituting n with 6. So I've substituted my n's with 6. -3 times 6 is -18 minus 10. -18 minus 10 is -28. -28 is equal to f of 6. If we have to evaluate the rule f of a equals negative 3a plus 5 to find the range, what does range represent? Y. Of the function for the domain, what does domain represent? X. Negative 3, 1, and 4. What this means that we're going to take the domain and substitute it. In this case, f of a means what? F of a represents y. So this a represents our x. So in order for us to find the range, we need to substitute each of our domains. That means we're working out this problem 3 times. This is where a equals negative 3. Negative 3a plus 5, where a equals 1. And then negative 3a plus 5, where a equals 4. This means negative 3 times negative 3 plus 5. Negative 9 plus 5 is negative 4. Negative 3 times 1 plus 5. Negative 3 plus 5 equals 2. Negative 3 times 4 plus 5. Negative 12 plus 5 equals negative 7. So this means our range is negative 7, negative 4, and 2.